Mr. Picard with a geometry lesson on the areas of parallelograms and triangles. Before we get started, I just want to discuss 3 preliminary points that we should be aware of as we enter into this. The first one is just a quick reminder about something called the perimeter. The perimeter of a polygon is the distance around the figure, always equal to the sum of the lengths of the sides. The reason we'll need that, aside from the fact that it's sort of useful to know how to calculate, is that when we get into some of the more complex polygons and we try to calculate their area, we will need to know what perimeter is in order to do so. Second thing, the postulate, the congruent areas postulate, simply says that congruent figures have equal areas. We should anticipate that. We know that congruent figures have the exact same size and shape. They are exactly the same in every regard, and so we would expect their areas to be the same as well. Third point is called the area addition postulate. It says the area of any figure is equal to the sum of the areas of all non-overlapping figures that comprise it. What that means essentially is that if I have a figure and I break it into non-overlapping parts, so for instance I have this shape that appears to be rectangular and I've drawn in what might be considered a diagonal, the area of this rectangle is equal to the sum of the areas of the 2 triangles. We'll use that particular rule when trying to find the area of more complex shapes. For instance, we'll never develop a formula to find the area of an L-shaped polygon, but we do have formulas for rectangles. So if we can find the area of the 2 rectangles, then we can easily find the area of the L shape. How do we find the area of a parallelogram? First of all, we need to talk about the area of a rectangle. Most of us are familiar with this by the time we're taking a geometry class. We know that the area of a rectangle is equal to the product of base and height. And so we simply multiply those 2 numbers to get the area of the rectangle. What about a figure that's slightly more complex? What about a parallelogram? It turns out that the area of a parallelogram is calculated with a very similar formula. Area equals base times height. We do need to distinguish this formula, area equals base times height, in the context of a parallelogram from this formula up here when we're talking about a rectangle. Here we have a parallelogram. In order to understand the formula for the parallelogram, I want to look at a particular shape. We'll take a look at this one on the screen. And I want to compare some of the values in this parallelogram to values that we may find in a rectangle. So in order to do that, the first thing I'll do is go ahead and draw in a perpendicular line segment from one of the vertices here. What I have done, you can see I have created 2 90-degree angles sort of in the right side. The next thing we'll do is move this small triangle we have on the right side, and we'll just relocate it over here on the left side. You can see that when we've done that, we have actually created another rectangle. If we were to ask the question, what's the area of that rectangle? We know it's base times height. So since the base of this parallelogram is the same as the base of the rectangle, I can use that variable the same way I would use it here. In other words, the base here corresponds to the base here. If I were to draw a parallelogram in here, it would look something like this. And so we find that the base is the same in both figures. Height is a little bit different though. When we talk about the height of a rectangle, it's very simply the side of the rectangle. We can see that here, you can also see it here. When I talk about the height of a parallelogram, however, we find that the height of the parallelogram is not the side, but rather the perpendicular distance between the base and the opposite side. So this is the height. Of course, we can measure the height anywhere across here. Typically, it's easier if we grab the height at one of these vertices. One of the reasons is because it forms a right triangle, and if we don't know height, we can calculate it using right triangle trigonometry in many problems. Note that the base of a parallelogram can be any of its sides. So when we come back to this figure here, it's tempting to think that the line located on the bottom of the figure is the base. We could just as easily use this side over here as the base. Let's see what that would look like. In order to calculate the area of this parallelogram using this as the base, we need to find the corresponding height. To do that, I'll just extend this base out. And when I've extended that base out, we can now find the corresponding height of the parallelogram, which lies approximately here. So we find here again that if we multiply this base by the corresponding height, we'll get to exactly the same area. In summary, then, there are at least two ways to calculate the area of a parallelogram. Which side, then, do we call the base? Whichever one will make the problem easier for us. So you have to choose that based on the information that you're given. Let's look at one quick example, and then we'll talk about triangles. Suppose this is a parallelogram. We'll stipulate that this is a 45-degree angle. And we'd like to find the area of this parallelogram. Suppose this side is 10 units, and this side over here is 8. How do we do that? The first thing we should recognize is that either of these can be the base. For this exercise, I'll choose the side that is 10 to be the base. So if 10 is the base, then the height that we need is here, the perpendicular distance from the base 10 to the opposite side. Okay, how do we find that value? Notice when I drew in that perpendicular distance, I've created a 45, 45, 90 triangle here. Because this is 8 and it's the hypotenuse, I can be sure that the leg is 8 divided by the square root of 2, which is the same as 4 square root of 2. So then area is equal to base times height, and the area therefore is equal to 10 times 4 square root of 2, which is simply 40 square root of 2. Now, as far as area, as far as the unit is concerned, I would say that it's square units. So it's 40 square root of 2 square units. That's how we find the area of a parallelogram. Let's talk about triangles. Most of us by now know that the area of a triangle is 1/2 base times height. When we move into geometry, we need to be a little more careful about that. We know that the area of a triangle is half the product of a base and the height. And the inference there is that there's more than one base, and in fact that is true. Any of the three sides of a triangle can be considered the base. It all depends on which one we want to use. So if I'm looking at this triangle here, any one of these sides can be the base. So if I'm going with AC as the base, then this segment, which I'll put a variable h, is the height. If instead we decide to use AB as the base, then this segment from C down to AB is the height. Finally, we could use segment BC as the base, and if we did that, then this segment would be the height. So once you choose a base, you have to find the corresponding height in order to calculate the area of a triangle. Once again, we might ask the question, which base do we use then? Which side do we determine to be the base? Whichever one's easier. Sometimes that takes a little bit of work where you have to sort of analyze the triangle before you get started crunching the numbers. Remember that when we talk about the corresponding height, it's always the length of the altitude to the line containing that base. Let's take a look at one example. I'd like to find the area of this triangle. I know the area is equal to 1/2 base times height. I know that base could be any one of these three sides, but that as soon as I choose base, I'm locked into a corresponding height. As I look at this triangle, I recognize that it's a right triangle. I could use the Pythagorean theorem to find the length of this side over here, but I also recognize that it's a Pythagorean triple, and so that side must be 3. So when I go to pick a base, I'm going to choose one of the bases that will have the perpendicular side as the height. So for instance, in this case, I might choose 4 for my base, and if I do that, 3 will be my height. That's preferable to choosing the 5 for my base, because if I choose the 5, I'll have to find the value of this altitude here, and since I don't know it, it's much quicker and easier just to use the 3 and the 4. So in this case, area is equal to 1/2 times 3 times 4, which is 6 square units. I recommend you work through a few practice problems. As always, if you have any questions, send me an email.